Hello friends, welcome to data structure course. Hi, I am Swapnil Chaudhary. In my previous video, we learned bubble sort. In this video, we are going to see insertion sort. Insertion sort. So let's see how insertion sort works. Suppose you have an array like 70, 60, 80, 50 and 40. Okay, this is the end of the array. So you have an array that is 70, 60, 80, 50 and 40. Now you are going to sort this array using insertion sort. So what happened? Initially we are create one sub array. Initially this 70 will going to compare with a 60. This 70 will going to compare with a 60. So basically we start from the index 1. This index 1 element is going to compare with the 0th index element. So what we find, the 70 is a greater than 60, then swap this position. Okay. Now next we are going to insert new element. Next we are going to insert new element, that is 80. Now this 80 will going to compare with the 70. This 80 I'm inserting 80. This 80 is going to compare with the 70 and then 60. So what we found, this 80 is greater than 1760, so it will place its proper position. Now next element we are going to insert, that is 50. Now this 50 will going to compare with 80. Now what we find, 80 is greater than 50, so we are going to swap their positions. So 60, 70 and here comes your 50 and this is what your 80. So what we insert new element, that is 50. Now this inserted element again going to compare with next element, that is with 70. Again what we found, 70 is greater than 50. So we are going to swap that 70 with 50. So here comes your 70, 60 as it is. This is 80, no change. Okay. Now we insert, now we are going to compare this 50 with a 60. So this 50 is a key element. Now what we found, 50 is less than 60. Now we are going to interchange their position. Here comes your 50, 60, then 70, then 80. Now next element we are going to insert, that is 40. Now this 40 becomes key element. This key element is going to compare with 80. What we found, 80 is greater than 40, so it will swap with. So what we get, here comes your 80 and this is what your 40. Then this 40 is going to compare with the next element, that is 70, 60 and 50. So 40 is less than 70, it will swap their positions. This 50, 60, 70, 40 and this is, sorry, not swap their position. So 40 comes here and 70 comes here and this is your 80. Then this 40 is compared with a 60. This 40 is compared with 60. So what we get, this is 50, this is 40, this is 60, then 70, then 80. Then at last this 40 is compared with a 50. So you will get 40, 50, 60, 70 and 80. So in this way we are going to insert the new element in this array. Okay. Now suppose I am asked you to insert the new element, that is 65. So now this 65 is inserted here. Then this 65 is compared with 80. So it will swap with 80. Then again it will compare with the 70. Then it is swap with this one. And then it is compared with the 60. So what we found, the 60 is less than 65. So updated array is like this: 40, 50, 60, 65, then 17, then 80. I'll skip some steps. That swapping steps. Okay. So this is way, in this way the insertion sort is work. The time complexity for insertion sort is big O of n square for worst and average case. So this is what insertion sort. Okay. Now there are some important characteristics of insertion sort. The first, it is efficient for smaller data set but inefficient for larger data sets since it is a time complexity of n square. Insertion sort is adaptive. That means it reduces the total number of steps if partially sorted array is provided as an input. That make it efficient. It is a better than selection sort and bubble sort algorithm. It is a better than selection sort and bubble sort algorithm. Its space complexity is less. Like bubble sort, insertion sort also require single additional memory space. And it is a stable sorting technique as it does not change the relative order of element which are equal. So this is all about the insertion sort algorithm. Now in the next we are going to see the selection sort algorithm. Selection sort is conceptually most simplest sorting algorithm. This algorithm will first find the smallest element in the array and swap it with the element in the first position. Then it will find the second smallest element and swap it with the element in the second position. And it will keep on doing this until the entire array is sorted. So it is called selection sort because it repeatedly select the next smallest element and swap it into the right place. Okay, then it is swap it to its right place. So let's take an example of selection sort. Okay, so suppose if you have an array like 120, 80, 180, 20 and 10. So what happens? Initially, I'm going to write this indexing 0, 1, 0, 1, 2, 3, 4. Okay, so 5 elements we have. So initially what happens? This 120 is going to compare with 80. Okay, so what we find, this 80 is compare with 180 is 120. So 120 is less than 80. So it will going to swap with this. So as per this 120, 80 is a smallest element. Okay, now this 80 will going to compare with 180. Then what we find? No swapping since 80 is less than 180. Now next we are going to check this 80. We are going to compare this 80 with 20. So what we found? 20 is less than 80. Then what we are going to do? We are going to directly swap this 20, 120, 180 and 80. We are just interchange their position. We are not disturbing other elements. Then at the 0th index, whatever element we have, that element will going to compare with the next element. Like from initially it will compare with a 120, then 180, then 80 and then 10. So what we found? So what we found, this 10 is less than 20. So this 10 will going to swap with 20. So 120, 180, 80, and here comes your 20. Here comes your 20. So in this way, we find most smallest element from this array. Now, in the next iteration, what we are going to do? We are going to compare. We are going to ignore this one. We are going to compare this 120 with 180. So what we find, 120 is less than 180. So there is no need of swap. Then this 120 will going to compare with 80. So what we find, 120 is greater than 80. So what we are going to do? We are going to swap it with a 120. We are not disturbing 180. So here 80 will swap with 120. Now at the index 2, whatever element we have, that will going to compare with the other element. So that is with 20. Okay, that is with 20. So what we find, 20 is less than 80. So we are going to swap it. So here comes your 20. Here 180. This is 120 and this is 80. So we are going to swap 80 with 20. Then next, what? This element is sorted. So this is second smallest element. Now this element is going to compare with 180 is compared with 120. So what we found, 180 is a greater than 120. So 10, 20, here comes 120 and here comes 180. And this is 80 as it is. So now this 120 is compared with 80. So what happened? 120 is greater than 80. So we are going to swap it. 10, 20, here comes 80, here comes 180 and here comes your 120. Now finally this 180 will going to compare with 20. So this 180 got swapped. So 20, 80, then this is 120 and this is 180. So in this way, the selection sort is work. So in selection sort, what we did first, we compare with the 0th index element with others. And whatever smallest element we found, we are going to swap it with a 0th index element. Then we are going to compare second index element with others. Whatever smallest element we compare with this element, we swap it. Then third, then fourth, and so on. So in this way, the selection sort is work. In this way, the selection sort is work. So time complexity, again time complexity of selection sorted, big O of n square. Big O of n square. Okay. So this is what selection sort algorithm. This is what selection sort algorithm. Okay. And space complexity of O of 1. Big O of 1. It is constant space complexity. Okay. So thanks for the watching video. Now next, in the next video, we are going to see the quicksort algorithm. Now, in this video, we are going to see the algorithm for quicksort or quicksort algorithm. Okay. Now, how quicksort works? Very simple. Suppose if you have a list of array, number of elements in an array like 52, 85, 70, 61, 45, 97, 91 or 40. So these are elements which is in your array. Now first what we are going to do, we are going to find the pivot element. So I am considering the starting element as a pivot element. So this is what? Pivot element. Now what I am going to do, I am going to sort this array into two parts. The element which is a less than 52, which comes into the first sub array, and the element which is a greater than 52, that comes in a second sub array. Okay, so the element which is a less than 52, which comes in a first sub array. Okay, so we are going to divide this array in a two parts. The element which is a less than pivot element in a comes in a first sub array, and the element which is a greater than 52 comes in a second sub array. So 85 comes here. This 70 is greater than 52, that's why it comes in this array. 61 again is greater than 52, it comes in second sub array. 45 is less than 52, that's why it comes in a first sub array. Okay, then 97 is greater than 52, it comes in a second sub array. 91 is greater than the 52, that's why it comes in a second sub array. Now 40 is less than 52, it comes in a first sub array. So in this way we partition this main array into two sub arrays, where the element which is a less than 52 comes in a first sub array, and element which is a greater than 52 which comes in a second sub array. So this is what a partition process. Now we are not thinking about a second sub array, we are going to consider the first sub array. Again we are going to find the pivot element for this first sub array, so which is equal to 45, which is equal to 45. So this pivot is equal to 45. Now what happened? The element which is a less than 45 comes in a, again I am going to partition this one. Okay, so here comes 40 and here comes null. Now this two partition is concatenate or conquer. So what we get, that is 40 and 45. Okay, so now this is a single array, so that is why we cannot divide further it. Okay, we have only two. So now we are going to conquer it, sort it by default. Now there is no chances to go further. Now we are going to think about this second sub array. So here what happened? This 85 becomes pivot element. So now we are going to again divide this second sub array into two parts. Like the element which is greater than 85 comes in a second array, and less than 85 it comes in a first array. So here comes your 70, 61 and and here comes your 97 and 91. Got it? Now again the likewise this I am going to consider this second part of this array. So 70 becomes the pivot element. 70 becomes, so I am going to write it again. So I am just going to consider this array 61. So 70 becomes the pivot element. So now we are going to divide this in two sub arrays. The element which is greater than 70 comes in a first, and greater than 70 comes in a second sub array, and comes in less than, which comes in a first sub array. So here comes your 60, here comes your null, means none. So by default then we cannot further divide it. So what we are going to do, we are going to conquer this. So what we get, final result, that is 60 and 70 for this sub array. Now we are going to think about this array. So now this one will become pivot array. The element which is greater than 97 comes in a second sub array, and element which is less than 97 comes in a first sub array. So here comes your 91. So we cannot further divide this arrays since we have only single elements. and then what we are going to do, we are going to conquer it. So what we get? 91, 97. So in this way we get this sub arrays in a sorted manner. See, 40, 45, 60, 70, 91, 97. Now again I am going to conquer this. So what I am getting, that is 60, 70. If I conquer, then 91 and 97. Now again I am going to conquer this with this. So what I get? This is 40 and 45. So final results comes like 40, 45, 60, 70, 91 and 97. So in this way we can sort the array elements in a quick sort. So what we did in a quick sort, we divide this array in a sub arrays till we cannot divide in a partitions. Okay, we cannot divide in a partitions. Got it? Then we are conquer whatever we divide that array, we are conquer their results at the end of the algorithm, and we will get the final result. So this is what divide and conquer technology. This is what divide and conquer technology. Got it? So what we did, we divided the array into sub parts and then finally get the final result. We conquer their result. We divide till the end of the array. Now the most important thing is time complexity of quicksort. So time complexity of quicksort for worst case. Time complexity. Worst case time complexity is big O of n square. Worst case time complexity is what? Big O of n square. And the best case average and best case time complexity 91 is like, I'm sorry. Okay. So, okay. Best case time complexity big O of n log n. So this is what? Best case. And also average, best and average case. Time complexity is what? Big O of n log n for quicksort algorithm. So this is all about quicksort. Thanks for watching.